So alright, as we mentioned in the previous page, for optimizing the query logical plans, normally we have three components, right? The first part is algebraic laws we can use for optimizing the queries or for receive the queries. So in this page, we show you with some examples for the algebraic laws we can use for changing the queries we have or we designed before. So the first group of laws we can use is called commutative or the associative laws. It denotes some operations we can switch the position of the relations, we can get the same results. And we show you with some examples for the union, intersection, as well as joins between two relations, as well as three relations, right? So given two relations R and S, if we want to compute the union between R and S, actually it equals to S union R, right? In other words, if we switch the position of R and S between after the union this operator, the result will be the same. It will be similar for the intersection given two relation R and S, and if we switch the position for the computing the intersection between them, and the result will be the same as well. And another case is for the joins, right? The join between two relations. And given R and S, if we compute R joins S, actually it will be equal to the S join R. So in other words, if we switch the position for the join operator, the result will also be the same. And so you can check this carefully by yourself, right? And you can also consider how to prove these kinds of laws by yourself. Besides the pairs of these relations, we can also compute apply these operators to three relations as well, right? R, S, and T. So given the relation R, S, and T, and if we compute the union R with the S union T, the result will be equals to R union S and then union T, right? In other words, if we compute the union of RS first or ST first, the result will be the same, right? It will be similar for intersection. If we compute the R intersection with S intersection T, the result will be equals to R intersection S and then do the intersection with T. And so if we apply the rules to the join operator, the result will be the same as well as shown in this page. So this denotes the commutative as well as associative laws for applying to these operators, union, intersection, as well as joins to the relations. And another rule or law we can use is called distributive laws. In other words, if we have three relations, R, S, and T, and if we want to compute the R joins, inside parentheses we have S union T, the result will be equals to what? Equals to R join S and the union R join T. So these are the laws we show in this page for combines different operators, right, with the relations. And you may wonder how to prove these laws, right? If you still remember, when we want to prove two relations or two sets, they are equal to each other, right? If we plan to prove A equals to B, right? How can we prove this? What we need to do is to show A is a subset. If we plan to prove A equals to B, we just need to show first A is a subset of B, right? This subset also contains equal, right? And B is a subset of A. And if we can show that A is a subset of B at the same time B is also a subset of A, then if so, then we can show A will be equals to B, right? It will be similar if we plan to prove the above laws like the R union S equals to S union R. We just need to show, right, this R equals to A, this R union S is a subset of S union R. At the same time, this S union R is a subset of R union S. And if so, then we can show this two will be equal to each other, right? It will be similar for the remaining ones, for the commutative as well as associative laws. As to the distributive laws, it will be more complicated, right? Once we have these two parts, we have A equals to this part, right? And B is this part. We just need to show that R joins S union T is a subset of the right hand side, right? At the same time, we just also need to show that the right hand side is a subset of the left hand side as well. And then we can show they will be equal to each other, right? So to prove this law, we can just use this simple method we show here, right? For denoting the two sets or two relations, they are equal to each other. We just need to show the left hand side is a subset of the right hand side. At the same time, the right hand side is also a subset of the left hand side. If so, then we can show the left hand side and the right hand side will be the same or will be equal to each other, right? Okay, so these are the laws, some of the laws we want to show in this page. Besides this, we also have some more complicated laws to be shown in the following pages as well.